Dear learner, I welcome you all to the MOOC on Principle of Electrical Sciences. I am Dr. Sanjay Agarwal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. Dear learner, in previous session we have discussed component of LT switchgear. We have also discussed different type of fuses, miniature circuit breaker, that is MCB, earth leakage circuit breaker, that is ELCB, and we have also discussed molded cage circuit breaker. Dear learner, in this particular session we would discuss what is electrical shock and what precautions against electrical shock can be taken. Then we would discuss earthing and its importance, different method of earthing, and what is the difference between grounding and earthing, and then we will also discuss factor affecting earthing installations. So first of all, we are going to discuss what is electric shock. When a person comes in contact with the live conductor, directly or indirectly, he or she gets a shock. That shock may be minor or severe. The severity of the shock depends upon the following factor. First factor is nature of the current, whether it is AC or DC. Since DC flows continuously and does not pass through zero current value in AC, so DC is considered more dangerous than AC supply. Second factor is duration of flow of current. Shock will be more severe if duration of contact with the live wire of a person is more. However, the severity of the shock can be reduced by disengaging the person from live wire contact immediately. Third factor is path of current through human body. Severity of shock also depends upon the path of the electric current through human body. A person has severe shock if current path involves is hard. Now we are going to discuss the effect of electric current when passes through human body. So when in human body the current flowing is around 1 to 10 milliampere, then he or she will feel prickling sensation. If that current is around 10 milliampere, then he or she will feel muscle contraction. The person remains stuck to the conductor. When current through the human body is 20 to 30 milliampere, then he or she will feel muscle contraction and it will cause serious paralysis problem. If current flowing through human body is around, you can say 70 to 100 milliampere, then there will be the cardiac problem and heart begins to vibrate and longer beats at a steady rate. This situation is dangerous since it is irreversible. Now, if current flowing through that human body is around 500 milliampere, then he or she will feel immediate cardiac arrest resulting in a death. However, electrocution should not be viewed in terms of the current alone but in terms of the current and voltage. A person gets electrical shock by coming in contact with an object that has different potential from his or her own. The difference in the potential causes current to flow through the body. The human body has known limit. Under normal dry condition, that voltage limit should be around 50 volt, and in damp surrounding that voltage should be around 25 volt. Now what precaution we should take against the electric shock? The following precautions should be taken as preventive measure from electric shock while dealing with electric equipment fitting or the appliances. So what precautions you should take care? First one is never work on the live circuit. Second, always stand on the insulating material such as rubber mat, wooden board while switching on the main switch, motor or motor switch, etc. While switching on the circuit, equipment, etc., you should ensure that your hands and feet are dry. Next important point that you should remember that you always avoid working at all those places where your head is liable to touch the live part. Next point, while working with the electrical circuits or equipment, never come in contact with the metallic casing, earth conductor, cross arm, etc. Next point is, while working on the high voltage circuit, avoid your direct contact with concrete flooring. Next point that you should take care, that is, never touch the person directly while resulting him from electric shock. And you should always take care that consider all the conductor as alive till you are not sure. So these all are the different precautions that you should take care against the electric shock. Now we are going to discuss earthing. The process of connecting metallic bodies of all the electrical apparatus and equipment to the huge mass of the earth by wire of negligible resistance is called earthing. When a body is earthed, it is basically connected to the huge mass of the earth by a wire having negligible resistance. Therefore, the body attains a zero potential, that is potential of earth. This ensures that whenever a live conductor comes in contact with the outer body, the charge is released to the earth immediately. Now, this earthing can be classified as neutral earthing and equipment earthing. Under neutral earthing, neutral of the system is connected to earth with help of galvanized wire. The neutral earthing is also called system earthing. Such type of earthing is mostly provided with star wiring. Under equipment earthing, such type of earthing is provided to the electrical equipment only. Under equipment earthing, non-current carrying part of the equipment is connected to the earth by the help of conducting wire. If any fault occurs in the apparatus, that short circuit current to pass the earth. Now we are going to discuss what is the importance of earthing. First point is, the earthing protects the personnel from the short circuit current. Second importance of earthing is, the earthing provides the easiest path to the flow of short circuit current even after the failure of insulation. Third importance of earthing is, the earthing protects the apparatus and personnel from the high voltage and lightning discharge. Now we are going to discuss how does earthing work. So here you can see in the figure A that in circuit there is a one fuse and one switch are there, and here you can see that single phase AC supply is connected between phase and neutral, and here you can see that one resistance R is there. This resistance R is of any electrical appliances or equipment, and here you can see that Ri is the resistance of the body, or you can say you can consider it like a insulation resistance, and this Rb is the resistance of the human body. So in normal condition, here you can see in the figure A, when single phase AC supply is connected across any electrical appliances, then current will flow through the fuse, switch and R. By any means, this live wire come in contact with the body of the any electrical appliances or the equipment. So in that case, what will happen? That means whatever resistance that you are considering as an insulation, that resistance will be the zero. So what will happen? Current will start to flow through the human body, as you can see in figure B. Right? Now what you have to do? You have to avoid such condition that current is passing through the human body. So what you can do? Just you connect the earth wire through that electrical appliances. So here you can see that there is another earth resistance, that is R suffix E is connected, as you can see in figure C, and this earth resistance is very less. So what will happen? As electrical short circuit occurs or live wire come in the contact of the body of the appliances, then what will happen? That current will not flow through the human body. Why? Because there is a earth resistance, and this earth resistance having a very less resistance in comparison to the resistance of the human body or resistance of the electrical appliances. So as you know, current always flows through the least resistance. So all current will flow through this earth resistance, that is Re. So by this way you can avoid to get electrical shock. Now when earthing is done, following points to be remember. So what are different points to be earth? First one is earth pin of 3-pin lighting plug socket and 4-pin power plug should be efficiently and permanently earth. Next point is all metal casing or metallic covering containing or protecting any electric supply line or apparatus such as GI pipe and conduits enclosing VIR or PVC cables or iron clad switch or iron clad distribution fuse boards, it should be earthed, or you can say it should be connected directly to the earth. Next point is the frame of every generator, stationary motor and metallic part of all transformer used for controlling energy should be earthed by two separate and yet distinct connection with the earth. In a DC 3-wire system, the middle conductor should be earthed at the generating station. Stay wire that are for overhead lines should be connected to earth by connecting at least strand to the earth wire. Now we are going to discuss types of the earthing. So there are different type of earthing. So first earthing that we are going to discuss, that is called plate earthing. Plate earthing requires a copper or galvanized iron to be buried vertically into the earth in an earth pit, dug more than 10 feet into the ground. In case of the plate earthing, these earth pits are then filled with charcoal and salt in alternate layers. Next earthing that we are going to discuss, that is called pipe earthing. So for pipe earthing, a pipe of galvanized steel is placed in the soil instead of a plate. The pipe is drilled with holes for connecting the earthing wire. The length and diameter of pipe depends on the type of soil and type of electrical installation. In this method, the earth pits are filled with alternate layer of charcoal and salt for inducing reactivity. Pipe earthing is the most common type of earthing that we use. Next earthing that we are going to discuss, rod earthing. Similar to pipe earthing, rod earthing requires the burring of rod made of copper or galvanized iron. Electrodes are embedded in the soil and so it decreases the resistance of the earth as required. Next earthing that we are going to discuss, that is called wire earthing. For wire earthing, several horizontal trenches are dug. Under wire earthing, strip electrodes are buried inside the trenches. These electrodes are made of copper or galvanized iron, or you can say steel. Sometimes round conductor are also used in the wire earthing. Next type of earthing that here we can understand, that is called earthing through the waterman. In this method of earthing, the waterman galvanized pipe are used for earthing purpose. Make sure to check the resistance of GI pipe and use earthing clamps to minimize the resistance for proper earthing connection. If stranded conductors are used as earth wire, then clean the end of the strands of the wire and make sure it is in straight and parallel position, which is possible then to connect tightly to the waterman pipe. Now we have to understand what is the difference between grounding and earthing. It is a very familiar that sometimes we say that grounding is done, sometimes we say earthing is done. So now we have to understand what is the difference between grounding and earthing. One of the major difference between grounding and earthing is that in grounding, the current carrying part is connected to the ground, whereas in earthing, the non-carrying part is connected to ground. So this is the difference between grounding and earthing. Now we have to understand the definition of the grounding. In grounding, the current carrying part are directly connected to the ground. The grounding provides the return path for the leakage current and hence protect the power system equipment from damage. Here you can see also in the diagram that here you can see that current supplies are there. Then you can see live wire and neutral wire are there, which is connected through that electrical equipment, and that neutral wire is grounded with help of the wire from the neutral to earth. When the fault occurs in the equipment, the current in all three phases of the equipment becomes unbalanced. The grounding discharges the fault current to the ground and hence make the system balance. Grounding has several advantages like it eliminates the surge voltage and also discharges the over voltage to the ground. The grounding provides the great safety to the equipment and improves the service reliability. Now we have to understand the difference between grounding and earthing in detail. So there are a different factor on which you can compare grounding and earthing. So first you have to understand what is the definition of the grounding and earthing. Under grounding, the current carrying part is connected to the ground. Under earthing, the body of the equipment is connected to the ground. If you are talking about the location, so under grounding, between the neutral of the equipment and the ground, grounding is done. In case of earthing, it is done between the equipment body and earth pit, which is placed under the earth surface. Grounding does not have zero potential, but in case of earthing, it has zero potential. Under grounding, it protects the power system equipment. In earthing, it protects the human from the electric shock. Now we have to understand the application. Grounding provides the return path to the current. In earthing, it discharges the electrical energy to the earth. Grounding are of three types. First one is solid grounding, second is resistance grounding, and third one is reactance grounding. Earthing may be classified as pipe, plate, rod, earthing through the tap, and strip earthing. If we are talking about the color of the wire for grounding is black and for the earthing it is green. Grounding is used for balancing the unbalanced load. Earthing is used to avoid the electric shock. An example of grounding are neutral of the generator and power transformer is connected to the ground. In case of earthing, the enclosure of the transformer, generator, motor, etc. are connected to the earth. Now we are going to discuss what are the different factors that affect the earthing installation. An electrical earthing refers to the transfer of the instant discharge of electrical energy straightway to the earth through the low resistance wire. Earthing is carried out through the connection of non-current equipment to the ground. It is done to ensure safety. Proper earthing installation can save you from any kind of electric shock by transferring the fault current flow to the ground. Many factors play a vital role in an earthing installation, and it is always important to take all of them into consideration before finally deciding on a particular type of earthing installation and the circuit that are required for this work. So some of the factors that affect the earthing installation are, so first factor is soil condition. The condition of the soil plays a key role in determining the efficacy of the earthing. The resistance of the earth, the salt and the moisture level of the soil tells earthing specialties as to how an earthing is made. For example, earthing is rocky soil is different from earthing in wet soil. Second factor that we are going to discuss, that is soil resistivity. Soil resistivity is another factor that affects earthing installation. Different condition of the soil provide different kind of soil resistivity. A majority of the soil conditions are not adaptable to earthing installation. Experts measure soil resistivity in ohm centimeter, or you can say ohm meter. Soil having a low resistivity is extremely corrosive. The resistive value of soil will be extremely high if the soil is dry, and if the soil has high resistivity, then electrodes earth resistance will be high. Third factor, that dissolved salt. Pure water is considered a bad conductor of the electricity. Soil resistivity depends on water resistivity, which then depends on the quantity as well as the nature of the salt that are dissolved in it. Next factor is moisture in soil. Moisture existed in the soil is tested by considering the amount of the water contained by the soil and its water resistivity. Hence, it is very important to provide water in the earth and around it for maintaining the moisture in dry climate. Next factor that we are going to discuss, that is location of the earth pit. The location where the earthing is done is also of great value. In case the earthing is to be done for a sloping landscape, hilly areas, rocky areas, water runs off. However, in dry climate, the water table decrease extremely fast. In this situation, the backfill compound is not workable for moisture as the surrounding the pit would become dry. Next factor is physical composition. A variety of soil composition offers different resistivity. Clay soils has 4 to 150 ohm meter resistivity range, whereas the range for gravel or rocky soils may be above than 1000 ohm meter. Next factor is that is climate condition. The climate condition also affect the earthing process. When the moisture in the soil increases or decreases, the soil is increase or decrease respectively. So in dry climate the resistivity is high and in monsoon the resistivity becomes low. So dear learner, in today's session we discussed what is electric shock and what precautions against electric shock can be taken. Then we have discussed about earthing and its importance. We have also discussed different methods of the earthing. Then we have discussed what is the difference between grounding and earthing. And in the last we have discussed what are the different factors that affect earthing installation. Hope you are able to learn all the concept. In the next session we will discuss type of the batteries and important characteristic of the battery. Then we will also discuss the ratings of the battery. Thank you very much.